This video covers the first chapter in the first objectives 1 through 5. The first objective here is the scientific method, and we talked about this in class, and this is from your own notes, so make sure you review that when you study for the test. Objective 2 is chemistry and matter, and it's pretty simple. This definition of chemistry, it's a study of matter and its properties. So this year we're going to be looking at matter in more detail and studying the properties of the matter. Matter has mass and takes up space, so we'll be studying anything that has mass and takes up space, which is pretty much everything on Earth. Matter also exhibits the property of inertia, so this is a piece that you may not remember or may not have talked about before when you discuss matter. Inertia just means it does not want to change, so if it's moving forward, it wants to stay moving forward, it does not want to stop. It's just a property of matter. Same as the reverse. If it's at rest, it does not want to get going, kind of how we feel in the morning. So inertia is the fact that it does not want to change. It wants to stay the way that it is. Objective 3 talks about two different types of data that we'll be looking at all year. This is qualitative and quantitative. Quantitative data, you can see the word quant in it, is numerical data. So data that uses numbers as quantities. Qualitative is data that does not use numbers as quantities, so those are the main differences. One does and one doesn't. So if you have something that's numerical, for example, I have 3,500 pictures of Devin and Kaylin. I probably have way more than that. I should go on my computer and check it out. You can see that number right there indicates a quantity. I have that many of them. So it's a quantity or a measurement. Qualitative, you see qualitative there, it doesn't really have to do anything with a number. So an example is I love taking pictures of Devin and Kaylin. So it's an observation. The sky is blue. Just the simple things, simple observations without numbers. Objective 4 and 5 then are going to look at chemical and physical properties and the changes. So these are different properties and changes. So we're going to discuss properties first and then discuss the changes and how they are different. Physical properties is just a characteristic of a substance that can be observed without actually changing the composition. So something that can be observed without changing what it is. So color, you can observe the color of something without changing what it is. The shape, the density, solubility, that's whether or not it dissolves, mass, odor, hardness, boiling point, and freezing point. So it may change the state it's in, and that's okay, but it's still the same thing. For example, water is still water even though it's frozen in ice form, or liquid form, or gas form. A chemical property is different though. This is a property of matter that describes the ability of a substance to undergo a chemical reaction. So a new substance has to form. So this is something that could, or will, or could potentially happen. It's not happening right now. So the chemical property is that it could happen. So iron can react, that's a key word there, with oxygen to form rust. So just know that this is the ability. It's not happening right now. Objective 5 then moves on to the actual changes. So these are different than the properties. A physical change is a change of matter from one form to another without changing the chemical composition. So, for example, you could boil something, or freeze something, or dissolve something, or melt, or bend, or crush, or condense, boil, break, or crack. All those things would not change the composition. So that's a change that it actually goes through that would not change the composition. A chemical change, on the other hand, is where a new substance is actually formed, so it's undergoing a change. So a chemical property states that something will happen. Remember up here is the ability to happen. Down here, it's happening right now, so the change is occurring right now. It's not going to happen, it is happening. So the difference is the iron is reacting with oxygen to form rust. So that's the difference there. Can, will, could happen is the property, is happening right now is the actual change. Looking at chemical changes, there's a few other things to talk about. There are the indicators of chemical reaction. We'll be using these in a lab coming up pretty soon. If you see a temperature change at all, so if it goes up or down, if you see heat, light, or fire, those kind of things will indicate that there's a chemical reaction going on. So even an explosion, definitely a chemical reaction going on. Another thing that you could see in a chemical reaction is a gas. So odor or bubbles are given off, so you could smell something potentially, or if it doesn't have any sort of scent, you would see bubbles because a lot of reactions occur in aqueous solution or in water. The third thing you could notice is a precipitate, and we'll see this in the lab. This is a solid that forms when two liquids are combined, so it kind of falls out. So when you think of precipitate, I know you usually think of probably rain, snow, sleet. it kind of is like that, but it happens in the reaction. So you see something fall out of the reaction. It precipitates out. The next thing to look at are parts of a chemical reaction. We have reactants and we have products. Reactants are substances that are present in the beginning of the reaction. So they're what you mix together or put together at the beginning of the reaction. Sometimes you may only have one. Usually if you have one reactant, you may have to add heat to get it to break down. Products, sometimes you may only have one product that are formed. Two things may combine to form one, but it could have more than one. So those are substances formed that are given off at the end of the reaction. So they're there at the end. So products make sense. If you think of production, the product is what you make at the end. It's what's there at the end, also in the reaction. So the general form, you have reactants yielding the products. So you have the reactants usually on the left side. Those are the things you mix together. And then you have an arrow that points to the products that are made. So if you take a look at the example, mercury 2 oxide decomposed to form mercury and oxygen. Well, looking at that, what's there in the beginning? Well, you have one thing, mercury 2 oxide. So that would be your reactant that would go on the left side of the arrow. Then you have your arrow. And what are the two products that form? Well, if you look at that, you have mercury and oxygen there at the end, it says. So you have your arrow, and then you write your products mercury plus oxygen. So that's a simple form of an equation. We'll deal with those a lot more throughout this school. You'll really be able to use those in our labs and work with them.